So I'm going to, for most of this, I'm going to be using just a couple of places to look around. One is Visual Studio Code, which is the editor that I usually use. If you're not got one that's already your favorite, I can recommend it. And partly because there's some useful plugins that make life easy for working on the project. And it works fine on both Mac and Windows and Linux as well. So the other place we'll spend a bit of time is in the console. So again, if you're using some variety of Unix, you'll be familiar with all the tools here. If you're using Windows, I recommend doing one of two things. It can all work straight in the normal Windows command line, but you have to remember to convert the slashes and things like that. What you can also do is install Git for Windows, which comes with a built-in terminal, a Unix terminal, which works pretty well for the sort of stuff that we're doing, and it means all the scripts will run. And of course, if you're on a modern version of Windows now, you can switch on the Linux subsystem, and you've basically got a small copy of Ubuntu running in the system there. And so when you open the terminal, you'll be able to do what you need to do. So things you've already done here are do a Git clone to check out the code base. And one of the things I will do every morning when I start work is a good habit, is just to check you know where you are and what you were doing. So Git status will tell me here, I'm currently on a clean branched of copy of master, so there's no changes on this particular checkout. That's because I just finished a branch and cleaned it out before I started here. Now I'm never going to do any work on master, so before I do anything else, I'm also going to want to create a branch, and we'll look at that in a second. So the third place we will spend a lot of time is in the browser, web browser. And so here, for example, is a copy of Voluntarily running on our Gamma site. And so I'll show you a few things about how we help to understand how to debug stuff from the browser side. The other places that you're going to spend some time are on the GitHub code pages. So here is where you'll be looking when you've done a pull request, and when you want to create a pull request, and when you want to comment on pull requests and see how things are going and stuff like that. And we'll walk through one of those, maybe not in this session, but in a later session. Gitter for the chat room you've already found, and it's quite handy to talk there. And now, of course, you can also chat with us in Slack. So then the other place where everything interesting is happening is on voluntarily.atlassian.net, which is both our wiki for documentation and our issue tracking system. And the place where you usually start looking here is on the Kanban board. This is where you'll pick up a ticket that's been assigned to you, or go looking for one if you're interested, create new tickets for the work that you're actually planning on doing, and move them through their life cycle from being in the backlog, ready to work on, and then done. Now this is running a little slow because of the video player. So here you go. So you can see here, this is me, and a quick click here tells me that I've got 2 items in progress at the moment, and one on the backlog on the selected for development that I'm should be working on but haven't. Normally you shouldn't have more than 1 or 2 in progress. The goal with this Kanban style of working is to pick up a ticket and just really keep ramming it forwards until it gets to done before you start something else. The idea is really, if you can when we break down tickets into work, we try to make them small enough that you can actually do that in one session, where a session might be a whole morning or a whole couple of days, depending on your work style. But you really want to be able to do it before you lose track of what you were working on. So let's start with a quick tour of the code base. So having checked out Voluntarily, the VLE2 code base, there's quite a lot of folders you'll have noticed, and then there's a few files in the root folder. The ones that are quite important are all the ones in capitals. So the first one is the code of conduct, which everybody who's contributing to the project should read, and if they don't agree to it, then they shouldn't get involved in the project. Contributing is really some just information about how you contribute to the project, which we're sort of covering now. And contributors is the list of people who've completed VT82, and we can see you're all here. The license is quite important. The Mozilla public license, this is essentially the definition of how we're open source and why we're open source. And the key thing to remember here is that if you introduce any other libraries into the system, they have to be compatible with this license. So the security policy there is pretty short. It basically tells you what you need to do to report a vulnerability, but there's a lot more information on the wiki about how security and things like that. The other files that are in there, some of these are just leftovers that we haven't cleaned out yet. The Docker files, for example, there is a build that allows you to run in Docker. And because it's a node project, the most important file that's in the root is the package.json. And the package.json does two things, really. One is it lists, these are all the scripts that you can run from the command line. So when we say run npm test or npm run dev or build or Storybook or Mongo, this is what's actually happening. These are the command lines that you're actually running. And if you've got something that you do a lot of, then it's quite reasonable to add another script to the package.json file scripts here. And then underneath here is the list of dependencies. So these are all the JavaScript libraries that we've incorporated into the project because they give us useful functionality. Some of them are pretty big. The Zeit stuff is all the next. We're using Mongoose. But what you'll see is actually, though there's quite a few, it's not that long a list. I think there's less than 50, and we don't add new packages arbitrarily. If you think you need a new package, you need to check with me to see if it's already functionality that's available in a package that we're already using, or whether it's sufficiently important that we should use a package and make a good choice of the libraries, because all of these expand the size of the project. The packages list are split into two. The first section, the dependencies, is the ones that are actually used deployed on the runtime system. It's actually used by the server and the client. And the second block, dev dependencies, are ones that are only used during the development, test, and build phases. And so it's a little bit looser here. You'll see Enzyme, for example, and Ava, which are our test libraries, sign on, and Standard, which is the linter. And so if there's a tool that you find that you think might be useful to assist debugging, like a security checker or something like that, then it's okay to install it as a dev dependency. Further down, there's some various configurations about how the test runner runs and what our thresholds are and things like that. But most of that you can ignore until the day you actually need to know all about it. The package lock is not a human edited file. It's adjusted whenever you update the package's JSON. And what it essentially does is keep track of what the versions of each library that we're using are, which version we're using and which versions we're okay about upgrading to as time moves on. So this allows us, as you can see, when you've got a lot of dependencies and a lot of the libraries that we use have their own dependencies, this file gets enormous. And so it represents quite a lot of code and a lot of other people's work. So there's potentially, one of these packages might come up with a security issue, and at some point we would have to bump up its version to make sure it's up to date. So normally, only somebody like me would go through and do upgrades, but if you start getting warnings, you may find that you want to do an upgrade, and then you'd have to check. Normally you wouldn't check in package lock, but if you've installed a new package, then you would have to. So just quick scan of these folders. A lot of them are, so all the ones starting with dot are essentially temporary, or at least not really part of the code base. This is like the VS Code settings and the output from the coverage tester and things like that. And then just running through them as we see them here. Assets is just a place for putting static data files that are used by the build or by the application. Here where you can see we've got a couple of that's style sheets that are used by the platform. Components, probably about 90% of the code is in the components folder. So every React component that you see, that we write, that you see on the pages, is somewhere in here, and it's we're divided it into folders usually by the entity that we're talking about, either the part of the page we're talking about when you see something like header, or the name of the page itself, like home, or in this case, activities and members and opportunities and organizations and people and things like that. So all of that, we try to keep together all of the controls and components that are used to represent people or interact with people and things like that. So here you can see person card, person badge, and we're keeping a fairly consistent naming convention here. So it makes it easier if somebody says, could you go and find the organization card or the org card and fix it? You've got a good idea that it might be in here. So one of the first things to know about Visual Studio Code is that there's a hotkey. On my machine it's Shift Command P, which opens up the general go and find everything tool. And if you just type in not Shift, yeah, just Command P, person card, and it will pick it out. So I've noticed sometimes people are hunting around the file browser here looking for the files they're interested in. It's almost never worth doing that. Try to remember you can either remember the name of the file and just start typing it here, or you can use the search here and just go looking for something that you know is in the file. That will save you time. Always worth learning the hotkeys. Will definitely save you time in the long run. So this tab here is the files, this one's the search, and this also does search and replace globally across a set of files. So be careful with that because it's quite powerful. This one here will show you any as we change files. So let's do a bit of that. So the first thing I'm going to do is switch branches. So I don't want to work on master. So I'm going to create a new branch, or I could switch to an existing branch. That's either one I've created or any other branch that somebody else has checked in. So if you're working as a pair, for example, one of you can create a branch and the other can then just check it out, and you can both collaborate on the same branch. Now normally when we create a branch we have a standard naming convention which is based around the Jira ticket. So it would be something like VP 1, 2, 3, 4. Actually I'll just use VP 82 for example here, and then I'll make this a tutorial. So it's essentially just saying this is the Jira code followed by any string that would explain why I've got this particular branch. There is also a second convention you'll see sometimes used, which might start with feature or bug, and then VP 82, and then something else. That's just it's also acceptable, but allows you to. It helps when you're trying to filter through branches to see what type they are. The reason we accept the first one there, you'll see later when we use the Atlassian tool. So I'm just going to switch to a new branch, VP82, Andrew's tutorial. So it's already changed the spaces to dashes so that so there's no problem there. So now I'm safe to create, to change anything or add new files and things like that. So if let's just go and look at hello. So hello is the simplest file in the system from the point of view of React. It is essentially the heart and soul of what a React component looks like. It's a function in this case. In this one takes no properties and returns a string. This is essentially just an unusual way of defining a string using a notation called JSX, which allows angle brackets to work a bit like quotes. And then this is actually the exact string that's returned because there's no substitutable parameters in here. So it's essentially a string definition, and when you use the word greet someone on some other page, you'll literally get this paragraph entity pushed into your page here. And then this is the next most complicated one, where we're passing in a property that's called name, and when we generate the paragraph, we're substituting the property name into the string that's output here. So it says hello Andrew or hello Jordan, for example. And if we want to see that in use, we might find that there's a test file. No, there probably isn't. So we'll come back and look at that in a bit. Let's just pick one at random. So here's an example where we've got a page being generated and it's got some content in it, and we could essentially go hello name equals Andrew, and that would then call that the original hello function. So if I just make a modification here, this is just like a random change. So you'll see on the list of changes here, it shows up. And if I just click on it, it will compare the copy that's on my local drive with the last committed copy, and you can just see that there's been a line added with some new stuff there. So this will always, when you're looking at your changes, you can always go through them and verify that you're actually changing what you want to change, and also at that point get rid of any things that you don't really want to check in, like you might have put extra comments in and things that you don't actually need. If I want to undo this back arrow here will just discard the changes and return it to the original. And this little document here will just open the actual document as well. So if you click on this side, you get the comparison, and if this side, you get the document itself. Now this plus stages the changes, puts them essentially ready to be committed, so that when you type a message in here, and I'm just going to put random change in here, and do the tick, it will commit that to my local copy of Git. So it's still not on the server. It's just in my local Git. And if I click the little sync button down the bottom here, it will sync both my new branch and that change to GitHub. And so now if I looked on GitHub at that branch, I should be able to see it. Okay, you'll get used to me digressing, but we'll just do a few little things as we go along. So all the components are in the components folder. Config has just got a couple of small files in. These are basically settings that are available on the client and the server. So rather than if you're reading things if you want to read things that might be in cookies or in the server-side environment, for example, rather than sprinkle those calls throughout the application, we try and collect them all here. So there's one object that's made available everywhere that has all the interesting values in that can change. You'll see here things like obviously the name of the application, and what server you're running on, what server port. Also things like the magic codes for authentication. What you'll find here is that when you're on test and debug, you don't actually need these, and they're pretty much ignored. So the secret access key to AWS isn't going to be used while you're testing. But when it's deployed to the server, then this environment, the Docker container that's doing the deployment, will have access to this key. And so you won't ever see any sort of production level keys are floating around. If you do, then let me know, because they shouldn't be there. Coverage is a folder that's generated when you're running the automated tests, and we'll come back to that in a bit. Docs is just some miscellaneous documents. Now most of the documentation is on the wiki, so the things that are here are a bit random from early days, so don't worry too much about that. Emails is a library for contains all of the templates for the email messages that we send out when you sign up and things like that. And these actually use a different templating language called Pug, which is pretty easy to read. As soon as you look at it, you think, oh, I get that. And if you used anything that content management system like WordPress or Django or something like that, you'll recognize this style of inserting blocks into page layouts rather than the React way, which is more to lay out the page from the top down. So we do the emails this way instead of React, because the people that are actually going to be updating the content in the emails are not necessarily coders, and this is a simpler pattern for them to follow, just with substitutable parameters and text and things like that. what you'll notice is that that does mean that these PUG files are all in English, which means if we want to do a second language, we have to reproduce all of these files in the new language. HOCs, that's a higher order components, which is a thing that you'll read about when you're using React quite a lot. Essentially, higher order components are a way of taking a component and then wrapping a little bit of extra functionality around it. We don't use it too much. What you'll see here is what we do is we use it to wrap a page to change its access status. So most pages are wrapped in public page, and so when you wrap a page in public page, it gets given a header component and a footer component, and that's about it really. So you don't have to worry about writing that bit. All the pages you write will just be content, and this by publishing it as a public page, it will get the header and footer. If you publish a page as a secure page, it gets a header and footer as well, but it won't let anybody visit it unless they're signed in. And if they're not signed in, it will just redirect them to sign in. And if you wrap something in the admin page, then if they're not an administrator, they'll see this access denied message. So keep going. So the lang folder contains the language files. So this is all the strings in the system get extracted from the code base and put into this table, which ultimately will get translated into other languages. We hope to go live with Mari as our second language, and then if we ever go international, then other people will have to translate it appropriately. So we've got the French one here just as a placeholder example. Don't edit this directly. It's always it's updated by changing the format, the translatable strings in the code base, and we'll see how to do that soon. Lib for library. This is miscellaneous functional files that do stuff that's used sort of in various different places across the application, most of those you don't need to worry about. Sometimes you might use call API, which is one of the ways you can your client code can ask the server for data or ask a third-party server for data. Node modules is where all of the installed libraries go, so don't look in that, it's enormous. And then we're into pages. So we're using this, as well as using Node and React, we're using this library called Next.js from Zeit. And it's worth reading through the pages there to learn a bit more about it. And what it gives us is several useful things that make our life as developers easier because we have to write less code. First one is that all of the pages that you have that are actually visitable URLs exist in this pages folder here. And so their path on the URL maps directly to their path here. So if we see an about folder here, then we know that there is a /about page that we can visit here, which is just some introductory text. So the fact that there is an act folder here, it has two child pages in it. One is called act detail page, one is called act list page. So in theory, we could go to act/act list page and we would see a list of activities. In reality, we don't do that because we've got some other roots in the system that just give them much more meaningful names. For example, here's a better example. The admin goals page is literally available on the site if you're signed in as, I have to sign in to do this. You'll find you'll need a fair handful of accounts to use in the system so that you can go into the system with different personalities, one as an admin, one as a volunteer, one as an opportunity provider, for example. And it's usually best to create your own so that you you can just delete them and change them without stepping on anybody else's toes. So this site here, the Gamma, is we've actually got 4 sites, 4 deployed environments at the moment: Alpha, Beta, Gamma, and Delta. Alpha is the site that you may have already had a look at, which is our sandbox at the tip of the code base. Every time a new pull request is put in, that version is automatically deployed to Alpha. So it always represents the most recent version. And one of the ways you can tell what version you're looking at is if you go and look down at the footer. I'll just pause. Yeah, so what you'll notice when you visit the different sites, this one, for example, is pretty busy because everybody has been chucking things in it for over a year now. And it's got, I can see this is only something that went in yesterday, these nice little markers on the cards here. So it's pretty new. Right at the bottom here, just above the footer, there's a version, and that includes the date. So this was 16th of March at 2059. This was last deployed. And this link, this code here is actually the GitHub commit that represents that push, that most recent version. If you click on it, you can actually see what the very last change that we put in was, which is this one change that Kerry put in that enables videos to be put into the rich text. So you can always go and track things back to the pull requests. So if I look at Gamma, for example, I've just redeployed it, so it should have the same tags on it. It should have the same value on, but it's connected to a different database. So if I look at compare the two, and look at the list of organizations, then what I'll see here is that this one's Alpha's got a lot of schools in it because TEC have been testing the school side of onboarding, for example, and whereas Gamma, nobody apart from me has been using, and probably it just has these 3 generic types of organization in. So we were talking about, so we're still working through oh yes, I was going to show you admin goals. So I'm signed in here as admin. How do I know I'm admin? It now should tell me, well, if I go to my profile here, one of the things it will say is it will list the roles that I'm in at the moment here, so I can see I'm admin. And we're just about, one of the tickets that's just working on is to color code the pages so that it's easier to tell. Because if you have admin powers, you can actually do stuff that you maybe not want to do on a live system, and so it requires a little bit of extra care. So if I'm admin, so I can go to, now we don't always put these on menus, but I can go to admin goals, and this is the place where we can reload the list of goals into the database and then allocate some goals to me. Haven't got the ability at the moment to allocate these goals to another individual, which would be quite handy at some point for testing. All right, so so what we're demonstrating here is that in its simplest way, routes you don't have to worry about. You can just create pages in the subfolders here, and they will show up on the website. So one of the folders that we have in this area here is test, and you can see there's quite a few here. So these test pages are little pages where you might want to, I've just written a new component and I want to see what it looks like. I don't want it to be embedded in the whole application so much. I just want to maybe put a few hard-coded values to see how it's going and things like that. So if I take a look at test-person, and at the moment these are all being deployed, but I think that by the time when we actually push to live, we'll actually delete the test folder so that you can't see it. And that's just currently giving me a blank page. So this is the trouble with test pages, is that they often haven't been touched for a little while, and so you can't see what's going on. Let's have a look at test member. Ignore that. There we go. So this is interesting. So this is actually demonstrating, you saw that page appear momentarily and then disappear again. So since I wrote the test page, something's come along to cause it to go blank at some point. Not a problem, but probably indicates that the test should be deleted to avoid people hitting the same problem. Okay, so pages. So pages, two things about pages. One is that they are, so everything that a real person visits is a page, ultimately, and then the page itself is built up out of components. And so, unlike parts lower down the system, pages in Next are allowed to be generated, rendered on the server side. And so what happens is that before the page is sent to you, all the components are rendered, and all of the data calls that are associated with those components are also done, and the whole resulting set of data is sent down to the person at that point. So the first time you click on a link, that happens on the server side. So this is a bit different to a lot of React components, where the first time you visit a page, you get a spinner which for a few seconds or 10 seconds or 100 seconds while it says I'm going to get the whole of the application, so a ton of hundreds of K of JavaScript down before I can even start asking for data and rendering the page. So this is what gives us a much faster initial rendering. So if we pick another one here, so I clicked on one of these here. It's still not the fastest, but it's pretty snappy, and you don't see any spinners while it's up and going. So the only time you might see a spinner is if you click on one of these sort of like a tab where this tab isn't normally open, so we don't fetch the data until we need it. In this case, there isn't any, but and so these like subcomponents may well do client-side requests for data, but normally a lot of the data is just handled on the server side, which makes it all more efficient. So the public folder is where we put in the static folder is where any imagery or other sorts of file that you just want to include in pages and you want a fixed URL for, that's where they go. So here you can see obviously the logos and things like that. Also, anything that needs to go in the root of the application, so the robots text and the this is where the icon should go, but I'm not sure where it's gone. Don't worry about that just yet. Okay, so then most of the rest of the stuff is in server, and that's this server.js is actually the beginning of the program. So when you are on the console here and you go npm run dev, what you're doing is if you look at the package JSON, so you're doing run dev, which is running node daemon. Node daemon is a utility application that when your application crashes, it will start it again. But it also, when your code is changing, node daemon is watching the files and will also restart your application. So it allows you to leave the application running while you're editing, and you can continue you'll see it restart. You'll see this little section here a lot when you're working on this project. There's two important things that you're looking for here. The fact that MongoDB is connected without an error, and the fact that the server has started without an error. So if you're running this, as you may have discovered when you're doing your own just recently, you need to have a copy of Mongo running. I'm using this local one that's just running in another window, but you can run it as a service in your and your system if you prefer. Or you can even set up the MongoDB URI in an environment file to point to a copy of the database on another server if you want to. Okay, so if we're looking at what it runs dev here, what it actually runs is server.js. And so sometimes people regard web applications as a bit mystical. There's like there's like no real clear beginning and end, and it just runs forever and handles requests and things like that. But it is actually just a perfectly normal command line application that starts here. And the first thing it does is it loads a lot of libraries. It loads Express, which is the web server, Mongoose, which is the database interface, and a bunch of others. Some of these calls are then Express, which you can, the Express documentation will tell you about. What we do here is we inject into the chain of requests as it comes in some middleware that says, decode any cookies, do some security, and check people are allowed to make the requests that they're making and things like that. We also set up the languages, so we look at people's browser headers coming in and saying which language they prefer to use, which is where here. And so if it's one of the, if you request the language that we support, then we'll set the locale, and then we'll change the messages over so that you are getting back the translated language file. This is where we start Mongoose. And so this is where you see the MongoDB connected coming out, or an error. We then scan for the router files, and we also scan for some things called subscription files, which are, because we use a pub sub notification system across the system. So when something new happens, like a new volunteer signs up for the first time, we publish a topic, and then other parts of the application can subscribe to that and do things like send emails or allocate gold cards to people when that happens. And then essentially this is where we get down to it. If we're in test, we run this line, and if we're in production or anything else, we run this line. So that's the test line, that's the Be Awesome line. So you can actually, if you're using a debugger, you can put a breakpoint on any of these lines and just hit run, and you will actually end up in the program at this point. And then once it steps into listen, then it's essentially running a loop that's waiting for an HTTP request to come in. And then by the time we next see it, we'll be in somewhere like about.js. So we'll be in here. The web server has identified which page we're trying to access, and then passes us in the request, so that we can actually render the output that we want to return at that point. With me so far? Okay, so really we're just trying to give you an idea of where things are. The other big part of our server is the API. So as you know, a full stack web application is broken down into a database or some sort of persistent storage, in which we're using Mongo, a web server or a server side, or a backend they sometimes call it, which is basically got the job of dishing out the pages and dishing out the answers to data requests, and updating the database in response to requests. So all of the files in here essentially are related to the entities in the database. So we use a very vertical structure for the way we organize files. Instead of having like all the controllers in one place and all of the data definitions in another and and so on, we have a folder for something like a person, and then we try and base all the server-side files for this entity are here. And so this pattern is repeated through all these different entities. So the first one that will always be there is just the same name. So person.js has got the schema definition for a person. And so this is when you look in the database, this is actually what you'll see. In fact, we can actually look in the database at a person. And and you can see that it's a JSON file with these tags and values and arrays and things like that. So there's a direct relationship there. So what Mongo itself doesn't actually need a schema. It's quite happy for you to put any as a store for any JSON document, and you can change. You can put different shapes documents in the same collection and all things like that. So it doesn't not too bothered, although it won't necessarily work the way you want it to if you do that. But what we're doing, what Mongoose is doing, is saying, well, let's, for the purposes of the middleware, let's understand what we're trying to do here. So although JavaScript isn't a strongly typed language, we are actually defining the types of things that we want here. So the name's a string, but it's an open-ended string. It's not like SQL. We have to say this has to fit into 10 characters and things like that. We are defining when fields are required and whether they need to be unique and whether they have a default value. One of the things we like to do here is make it very hard to get it wrong and have a validation failure. So if a field is required, we'll always provide a default, except in the one case when you cannot, which is the unique identifier for the item, for example. So most of these things are just strings. A lot of the entities have some enums in them, and where we're using enums, we usually try to predefine the constants that define the enums. Though in this case here, you can see we're still using just fixed strings for that simple one there. When we try to make the entities like as small as possible, this one's grown like Topsy, but if a special case requires you to add extra values, then what we prefer to use is a subdocument. Here, for example, we've got some special information just that only teachers put in, and so we use a subdocument rather than expand the original document. Then we've got some various Mongoose plugins, things that are essentially validating IDs and references, controlling whether you're allowed to get and set certain fields, for example. Okay, so alongside a schema, then the next thing you'll find is that we have to link the API call to the controllers that actually return values. Now, typically in a lot of applications, this involves quite a lot of boilerplate, so the same functions written over and over again. So we're using this library called Mongoose Crudify, which will give us automatic definitions of the create, update, delete, read, and list functions. So we only need to override the ones that we want to be different. The defaults are pretty open, so if you've got something that's public for everyone and such like that, then you don't need to have any overrides. You can see here in people, there's quite a lot of specific stuff going on, so we have actually overridden most of the functions. But we still use the Crudify tool because it allows us quite easily to inject middleware such as the authorization and sanitization. So we're trying to use, not have to rewrite code, and if anywhere you see duplicated code, then there's always a question about whether it should have been factored out, for example. So then that would lead you to the controller. So this is where something as straightforward as get. So I'm presuming you're familiar with RESTful API calls where you're making, if you make a get request to a resource, which would be something like API/people, you'll get a list of people back. And then you might use query parameters to filter that list and sort it and limit it and things like that. But if you make a get request to API/people/ some ID, then you're going to get the details of that particular resource. And so what we see here is we're using the phrase get to get a particular person, and we're using the phrase list to say this is handling a request for a group of people. And this pattern that you'll see here is quite common across our code, where we've got standard parameters Q, S, and P, which map onto querying for by a particular field, so you're looking for people by email or people who live in a certain area and things like that. Sorting and selecting, which is using P because the function is called product, and that's saying, well, I don't want to receive everything back, I just want to receive a few key values. So one of the things that you might get to be using this sort of interface quite a lot, because if you're trying to develop dashboards and to get data out of the system for analysis and things like that, then you're going to be able to want to make queries based on quite a lot of different criteria, for example. The rest is, if you're happy reading the code, the rest is reasonably self-evident. When it gets complicated, it's usually something to do with security, which we'll cover another day. That's in these ability files here. So the main entities that we've got going on are, so yeah. So an activity is a template for a thing that you can do. So it might be like an OMG tech activity to build robots to find their way through a maze. It might be a TEC activity to have a bunch of people from industry come and talk to you about their jobs. It might be an activity to do some a gee-whiz chemistry thing or launch a rocket, but it doesn't actually exist in real time and place. It's essentially a how-to, or it's a document that says this is what you can do. The metadata surrounding it will tell you who it's appropriate for, what school age, and things like what equipment you'll need, and especially for us, how many volunteers you'll need to actually to do it. So activities are the sort of starting point. They're the templates, as it were, of things to do. And then when somebody comes along and looks at activity and they say, oh, that looks interesting, and if we actually go and find one, okay, got to choose the right version. What you'll notice actually is that we try to be very consistent of our terminology in the code base and under the hood, but what we actually put in front of customers, the names change. So for example, the activities list is under resources here. Because although we use, for example, the term opportunity, it doesn't necessarily mean anything to the customers. So here's a bunch of activities. Here's one I made earlier, as they say, and what we can see here is there's a lot of these entities have a few things in common. They're almost like inheriting from a base class. Everything has a name, everything has a subtitle, everything has an image, and usually has a description. And that allows us to do things like use consistent layouts for cards that summarize we know there's going to be a picture, we know there's going to be a name. So although it might make more sense for it to be called title, but people have names and opportunities have names and activities have names, and so that's why it's more useful for us to be consistent than it is to necessarily turn this into being a title. So this is a pretty standard layout for us. It's getting quite mature now. We've got we've got tags. Tags associated with how you find the right thing that you're interested in doing, and how we also match up volunteers with activities. The sort of requirements you've got here, and some downloadable documents which may tell you about the science behind the subject and what you need to do on the day and things like that. So if you're an activity provider, so all of these entities are owned by somebody, and so what we do is everybody who's in the system needs to belong to an organization, and they get their abilities from that organization. So if we have an organization that's an activity provider, in this case Acme Activities, then anybody who's a member of that organization is allowed to create activities. And so as a super admin, I can see that this particular system's just got one AP admin. This is essentially, not a real person, but a test. So here's some would be some telling you how wonderful Acme Activity is and things like that. You can see that there's some layout polish still needs to be done here. And under the offers here, you'd expect to see the list of activities that this organization provides, and that's still on the to-do list. Somebody should do that in the next couple of weeks. So if you're a teacher, you're searching through this, looking for things that you can do that are appropriate for your class, and then you're going to say, I want to run this activity. So now you're going to convert it into an opportunity, and it tries to fill in as much of the detail already from the activity. But I'm going to do this, and I'm going to do it at this junior high school. And the key thing here is I'm actually turning the theoretical idea of a thing to do into an actual thing to do, because we're going to do it on March the 31st, for example. And we're going to do it somewhere in Auckland at this normal school. It's already got some tags, but I might add some more tags. So I might add year 12, for example, so that we're now looking for how we attract the right volunteers to the activity. And I can save that as a draft or publish it. Okay. So that's actually now, if you look at the URL here, that's actually it looks the same, but it's been turned into an opportunity. And if I sign in now as volunteer, I can see a button that lets me say I'm interested, I get involved in this project. So the activity is the first big entity. Everybody's a person. Everybody has a profile which they can edit, they also fill in tags. Tags are going to be quite useful, important to us in terms of determining impact as much as matching and things like that. This list of personal information is going to gradually expand, so we're also going to start to try and have more metadata about the person. So we already know what education level they are at, what their job title is, and things like that. So if we're trying to work out, are we getting the right people in the right place? Do we have any inherent bias in the system and things like that? We're going to start having certain amounts of metadata built into the system so that we can generate reports based on that. So we've looked at person, activity, opportunity. So those are the big three. That's the triangle that is the Voluntarily logo. There's a couple of what we might call join classes here. Interests and member. So member is essentially a relationship between a person and an organization. So as you can see here, it is just a person and an organization and a status, whether you're a follower or a member or an admin of the organization. So no SQL systems don't typically have relations. That doesn't mean you can't make relationships, and it's certainly in the system we're using, this is pretty close to a join table. The difference is that when I find a member record, I don't have to do any further lookups. I can populate out those IDs with the specific data I'm looking for. So what these getters do is build a document that isn't necessarily everything in the database, but is the bits that I need for this type of request. So this is equivalent. So we're effectively doing a join and select if you're familiar with SQL. Most of the things you can do in SQL you can do in Mongo, but they may be more or less efficient depending on how the database is designed. So we certainly don't fully normalize the system. We actually carry a little bit more data around than needed, just because it's actually very convenient to do so. The other big join is the interest. So this represents the relationship between a a person and an opportunity. So when you say, I'm interested in doing this opportunity, you'll get a new interest record and you'll be interested. And then when the teacher looks at that and says, yes, you're definitely the sort of person we want to come, you'll get invited. And then if you accept that invitation, you're committed. If you're not the sort of person they want you to come, they might politely decline to take you because, for example, you might be in the wrong location or not available on the right dates and things like that. Not because you're a bad person. We also carry now, along with these, because this is an object that effectively reflects the life cycle of your relationship with an event. Each time that state changes, we're giving people opportunities to converse effectively, send messages between the teacher and the volunteer. So if I'm looking at this from the point of view of the organizer, I've got this person here who's said they're interested. I can invite them or decline them, or I can just send them a message to say, well, would you be available on the 31st, for example? And this builds up a little history, a little chat history of the exchange, which is being stored in this message schema here. So this is an example here where we've got a little sub document that's actually an array of messages that's being built up. So each one carries its own rather than there is no separate collection of messages, which is what you would do in SQL. Okay, that's enough of that. The other entities are sort of fairly self-explanatory. When you come across them, you get to know them. And so just to finish the X folder, so anything, so there's a lot, usually a bunch of housekeeping that you have to do when you're running a full stack system. So all of the sort of command line scripts that are available to do admin stuff are sitting in the X folder, so that it's conveniently to type x/aws/deploy, for example. So the AWS stuff has got the scripts that build our entire deployment and deploy versions to them. You won't be able to do these unless you actually have a valid login, which you won't. But if you set up your own AWS system, then you can actually use them. The Atlas, similarly, this is the database access. And there's a couple of useful ones here which you I think just used, which was in the DB ones to initialize, to set yourself up as admin. And I'm literally just about to check in one that will build your entire system with data. So it will create a whole bunch of organizations and opportunities and things like that, so it's ready to roll. And because you're going to be working on you want to be looking at you want to get a large data set that you can then sort of do an analysis on. So you'll probably take those tools and then extend them, because one of the ways you do data science is that is like you start with the answer you already know. So if you're expecting to get a certain statistic out that there were 15% of people accepted, then you need to be able to create a database that has that value in it so that you can prove that your maths is correct.